So in this video we'll be talking about how to integrate the function radical x plus 1 over the square root of x times the cubed root of x plus 1 dx. To begin, what we're going to do is something that might seem sort of a little bit too complicated to work, but actually ends up working out in the end. So the first thing that I decided to do for this integral is to let x equal u to the sixth. And in this way, u is equal to x to the 1/6 power. When we take the derivative of x, what we find is that dx is equal to 6 times u to the 5th dx. Now, before we can proceed with this problem, we have to sort of get clever with the way that we use our assigned values of x and u. And one way that we can do this is by taking into account the fact that radical x is equal to x to the 1/2 power, which also happens to equal u to the 6th power to the 1/2 power. Or in other words, x to the 1/2 power is equal to u cubed. And another thing that follows from this is that the cubed root of x is equal to x to the 1/3 power, which also happens to equal to u to the 6th all up to the 1/3 power, which is just equal to u squared. Now, if this seems confusing, it's because it kind of is. We make use of the fact that x is equal to u up to the 6th power, or in other words, wherever we see x here, we're going to replace it with our u to the 6th power. And in the case of x to the 1/2 power, it's simply our u to the 6th power raised to the 1/2 power, which we then can simplify to u cubed. And in the case of x to the 1/3 power, we replace the x with u to the 6th power, and then we just raise that to the 1/3 power as we did with this x, which can be simplified to u squared. Okay, so now that we have all of these values for our u, we can begin to modify our original integral in terms strictly of u. So what we have is that our integral is now equal to u cubed plus 1 over u cubed times u squared plus 1, and wherever we saw the dx, we're going to replace it with our value for du, and our value for du, let's see, I believe this should be du actually, my mistake. Our value for dx is equal to 6 times u to the 5th power du. And now that everything is in terms of u and du, we can continue to integrate our function. And the first thing that we're going to do is we're going to move this constant, the 6, to the very front of the equation. And what we're left with is 6 times the integral of u to the 5th power times u cubed plus 1. And we get this u to the 5th power simply from this 6u to the 5th power after we move the 6 to the front of the integral. And this is all over u cubed times u squared plus 1, just as it was over here, du. Next, what we're going to do is we're going to actually simplify this. We're going to get rid of this u to the 3rd power, and this is reduced to u to the 2nd power, u squared. And we're then going to distribute that u squared into the numerator. And what we're left with is 6 times the integral of u to the 5th power plus u squared all over u squared plus 1 du. Now, at this point, what I want to do is I want to go ahead and I want to use polynomial division to simplify this integral. That way I don't have to use any more calculus techniques before I integrate this function. And really, it's not too difficult if you have some experience doing this type of long division, but I'll walk you through it in any case. So we have that this u to the 5th power plus u squared is being divided by u squared plus 1. So that's going to be over here, and the numerator is going to be inside of the it's going to be the one that's being divided. And our first step is to try to get rid of this u to the 5th power, so I assign this to be u cubed. And next, I have to keep in mind that this is all going to be subtracted, so u squared times u cubed is equal to u to the 5th, and 1 times u cubed is equal to u cubed. When you distribute the negative sign, what you're left with is negative u cubed plus u squared. Now that I'm trying to get rid of this negative u cubed, I have to assign a negative u here That way, when I multiply u squared times negative u, I'm left with negative u cubed, and when I multiply 1 times negative u, I'm left with negative u. I have to keep in mind that all of this is being subtracted, and therefore I have to distribute this negative value on the outside of the function, and what I'm left with once I distribute that is u squared plus u. Now we can further simplify this, and what that looks like is u squared plus u. I'm going to assign a value of 1 here, and then 1 times u squared is equal to u squared, and 1 times 1 is equal to 1. Keeping in mind this negative sign here, I go ahead and distribute that, and what I'm left with is u minus 1, which is actually not able to be divided further, unless I want to make it more complicated, and this remainder is actually going to be reflected as a fraction after we've simplified our polynomial equation here. And so I'll take the product of this division here, and keeping in mind that I have a 6 on the outside of the integral, I have 6 times the integral of u cubed minus u plus 1 plus whatever our remainder was over what it was being divided by in the first place. So it's going to be u minus 1 over u squared plus 1 du. And now I'm going to further simplify this by splitting u minus 1 over u squared plus 1 into two separate fractions, namely u over u squared plus 1 minus 1 over u squared plus 1, and keeping everything that we had before. And now what I'm going to do is I'm going to separate all these integrals, and I'm going to independently integrate them. And once we're done with all that, what you should be left with is the 6 on the outside times 1/4 u to the 4th power minus 1/2 u squared plus u from this 1 plus 1/2 the ln of the absolute value of u squared plus 1, which we got from this integral here, minus the arctan of u, which we got from this integral here. And we can't forget our constant c. Now, we're not exactly done with this problem because the equation was given to us in terms of x, so now we have to go ahead and convert all of our u values to x, which shouldn't actually be very difficult because we already have a definition for our x, and here I've written that we have to plug in our x values given that u is equal to x to the 1/6 power. So when we go ahead and do that, we're left with this fraction over here, this entire equation over here, and I haven't distributed the 6 yet because I want to make sure that everything is fully simplified before we move forward. So we have 6 times x to the 1/6 power all to the 4th power, because remember, we're taking this u to the 4th power, and everywhere we see u, we're plugging in x to the 1/6 power, over 4 minus x to the 1/6 power squared, which we got from this u, over 2 from this 1/2, plus 1/6 x, which is directly from this u, given the fact that u is equal to u is equal to x to the 1/6 power, plus 1/2 times the ln of the absolute value of x to the 1/6 power squared, which we got from here, plus 1, minus the arctan of x to the 1/6 power plus our constant c. Our next step is to distribute that 6, and what we're left with is 6/4 times x to the 2/3 power minus 6/2 times x to the 1/3 power plus 6x to the 1/6 power plus 6/2 times the ln of the absolute value of x to the 1/3 power plus 1 minus 6 times the arctan of x to the 1/6 power plus c. And because that's not enough, we're going to go ahead and simplify it even further, which will lead us to our answer of 3/2 x to the 2/3 power minus 3x to the 1/3 power plus 6x to the 1/6 power plus 3 times the ln of the absolute value of x to the 1/3 power plus 1 minus 6 times the arctan of x to the 1/6 power plus our constant c.